Now there are several tests we can make when we're troubleshooting a starter. Tests like voltage drops. We can load test a starter, and we'll even show you how to shim a starter properly. But before we dive into the starting system, like always, you have to have a properly functioning battery. It has to be fully charged. It has to be able to deliver the amps to the starter to make it work properly. And to do that, the first thing always is a visual inspection. Just take a look at it. Look around all the terminals, make sure they're secure, make sure there's no corrosion, look for any leakage, make sure that the hold down's secure, and everything's good on the battery. If it looks good, that's fine. You can go into an open circuit voltage test. If it doesn't, then you want to get some battery cleaner. You want to take your terminals off. You can use this tool right here. You can actually clean all the terminals on the battery, make sure they're in good shape, whether it's top post or side post. It doesn't make any difference. You don't want any voltage drops, and we'll look at that a little bit later. Some dielectric grease, so you got a good connection and you're getting full voltage potential down to the starting motor along with the amps. Now, the first test I like to make is just open circuit voltage, and that's real easy. You take a DVOM, a digital volt ohm meter, and you just set it down and you go across the terminals of the battery. I'm in DC voltage, and if I put the negative on the negative and the positive on the positive here, and I look down, man, I'm at 1310. So we got a fully charged battery in this vehicle. We're ready to go. At least we can load test the battery at this point and make sure we have full voltage. Jace, you have a load tester. Let's take a look at that and see if this battery is actually going to hold a load. Just because it has 13.10 volts doesn't mean it can actually deliver the amps we need it to deliver.
Exactly. Once you hold this tester, and it's an easy tester to use. You just want to hook it up to the battery, positive first, go into the positive side of the battery, hook him up, then the negative side, and then all we got to do is follow the prompts right on the screen. You see right here, it's got out of the vehicle test or in the vehicle. We're going to go ahead and go down to in the vehicle, hit go. It says choose the type of battery. Is it a conventional battery or AGM? We have an AGM battery, so we'll hit down, showing our voltage, and we'll hit go. Now it wants to know our cold cranking amps. We'll hit enter, and then we'll have to go down to our battery, look at our label, and ours is 750. Then we'll hit go. Now it's waiting to stabilize the battery. It's doing our first load now.
So actually it goes through the load test. Once it goes through the load test, it's going to actually take some of the amperage out of it. If you have a carbon pile load tester, you want to go ahead and cut that in half and load test it for about 15 seconds. So cut the cold cranking amps in half if it's a carbon pile. This is a conductive tester. This is actually just penetrating the plates and able to tell if the battery's in good or bad shape. But keep this in mind. Check out this chart right here. If you look at a battery and you go with that open circuit voltage, and let's just say, for example, you got about 12 volts in there. You know, that's 50% charged. You would think that's a full battery. Even at 12.4 volts, that's only 80% charged. So you want to get 12.6 or higher.
All right, the next thing is prompting us for us to proceed with starting charging test. We're not going to do that, so we just select down. And now here we go. Our battery is good. Our OCV is 13 volts. Our cold crank, it's 944 amps. This battery is good to go, John.
This battery is in good shape. Well, now that the battery is in good shape, we can turn our attention to the starting system. And you know, I got a cool demo set up over the board. We can look at voltage drops, potential voltages, and how the system actually works. Let's perform some voltage drops on a starter system. But before we do that, let's understand basically how it works. And it's pretty simple. You turn the key on and it runs the starter. The key is going to go through power and it's going to go over here to a neutral safety switch. Now, you know your car only starts in park and neutral. That's a neutral safety switch that does that. Now, newer cars may have modules in there with anti-theft systems and some other things that stop the starter from enabling and running. So you want to check that too. If we don't have power on this other wire, we'll look at it in a minute. But just think about that for a minute. We come down here, we're going to run through a relay over to a solenoid, and the solenoid is going to make the contact from the power down to the starter and get the starter to run. Turn the key, starter runs. Now those voltage drops, very important. Voltage drop is checking for resistance, unwanted resistance in the circuit. We saw earlier, first place to start is the battery. So I'm going to go from the positive to the negative and make sure we got proper battery voltage. And our demo here showing 12.8 volts, we got enough voltage to run the test. Then what I want to do is I want to do a positive side voltage drop. So I'm going to go on the positive battery cable, and then once I get on the positive battery cable, I'm going to run the other lead up here to the positive cable going to the starter. Now what's that catching? Everything in the system. I got all the way here, the battery coming back, the cable coming back to the relay, all the way back to the battery. So if I have a voltage drop there, I'll have to isolate it piece by piece. But what you want to do to get the voltage drop is run the starter. You want the amps to flow, the current to flow through the actual circuit. So what I'm going to do is I'm going to turn it and run it. When I run it, we'll look at the meter and we'll see if we have any voltage drops. So it's fluctuating about 0.1 or 0.2, a tenth to 2/10, that's fine. On the positive side, really 3/10 is acceptable. 2/10 on the ground side, that's 5/10, a half a volt throughout the whole system. But that's just the positive side. We're going to check the negative side as well. So to check the negative side, I'm going to come over to the battery. I'm going to go on the negative terminal of the battery, and then starters are case grounded. So once I go on the negative terminal of the battery here, I want to go to the case of the starter. This is important because they have to return home. All those electrons got to get back to the battery, so this is going to check the voltage drop. Now if we had a voltage drop on the ground side, you want to check for any bolts, securing bolts, any dirty mounts or anything that's going on to where it's actually not going to make a contact with the frame, even to the point where all your ground straps and your ground returns back to the battery. Now I'm going to go ahead and start it again because we want the electrons to flow. When I do that, watch the meter. Let's see what the voltage drop is on the ground side. Same thing, 1 to 1.2, it's in pretty good shape. Now, on our positive side, we had a little bit, negative side, we had a little bit, we were in. But if we had a little bit more, let's just say, for example, on the positive side, we can take it one step further. We can actually start to isolate it. Maybe it's just the contacts in a relay. Maybe it's just this piece of wire from here to here. You can check all those. So I can go from here to here to check it, or I can go across the contacts. And if I go across the contacts here, you're going to see 12 volts because it's not engaged and it's grounded out. But as soon as I start the starter, what's going to happen is the contacts are going to make the plunger come out and it's going to make contact, and we're going to watch the voltage drop. So let's just watch the voltage drop of this relay alone and see what it is. Hardly nothing, so that wasn't the problem. So a little bit of the voltage drop was probably in the cables, perhaps mounting to this board. Even the positive and negative battery cables could be slightly loose, but you can go isolate them a little by little. Now a couple things to check for. If that relay or that starter solenoid's bad, you can see I got one down here. And what happens is when you turn the key, it actually magnetically pushes the solenoid out and it makes contact with these two little posts right here. It's taking the bat terminal and it's sending it down to the motor terminal. This is a massive amount of amperage. So if any of these lugs are loose right here, or this thing's not coming out, let's say you have a voltage drop prior to getting to this and you're not getting the magnetic induction you need, this thing's not coming out making a good contact, you're going to get burnt contacts like this. Well, guess what? There's your voltage drop right there. If I'm running that starter with low voltage, I'm doing damage to the starter. It's going to cook the armature, it's going to cook the commutator, all kinds of things go inside in there you don't want to happen. Now here's some forms of voltage drops. You can actually have wires that are crimped, that's really not crimped real well. Well, those electrons, those atoms, they can't run through there. So what's happening, it's a restriction. It's like a hose. It's not going to get there. Here's one right here. It may be frayed internally. This is why I don't like to use resistance, because this one's going to show up as fine if I do it with resistance, but if I try to push some amps through there, this is just a fusible link. This thing's going to burn in a heartbeat. Also heat. Make sure that you run into these starter wires right here. I have all this heat damage right here. Heat introduces resistance into the starter circuit. Also the length of the cable. If you run the length of the cable and the cable gets real long, that's causing resistance, just the air alone. So make sure you route everything away from the heat to the length you need, make sure all your connections are secure, and use this voltage drop method when testing your starter system. Well, we know our battery's in good shape and we know we don't have any voltage loss due to our voltage drop checks of our starter system. Now we can actually look at the cranking amps it takes to run the starter, and that's called a load test on the starter. In order to do that, we're going to use our VAT45, and it's really simple to do. What I'm going to do is I'm going to take the positive, put around the positive cable, the negative around the negative, and we'll let the machine initialize and start up. But remember earlier, we used a conductance tester to test the battery. Well, we can load test the starter with this one as well. It's simple, just hook it up, follow the prompts. It'll tell you the cranking amps that's going on when you crank the car over. But I want to do this one so you can actually see it time out and you can see the amps on it as we start to crank the car. Now, a couple things to do. We want to put the probe on. But this time we're going to take our amp probe and we're going to put it around the positive cable going down to the starter. Well, why are we doing that? Because we want to read amps. Well, the amps are running when we crank it through that cable to the starter, and this one's going to count them. So I'm going to put it around the cable going down to the starter, which is located right here. The positive ones, that's the hot lead to the back of the starter. And then what we're going to do is just simply follow the prompts. I come over here and I scroll down to starter. That's what we're going to do. I hit yes, which is enter, wants us to disable the ignition. Now this is important because we want to crank it over for an extended period of time for it to read the amps that are running down to the starter. Now you can do it several ways. You can actually pull the fuses on the fuel pump or different methods. This one's pretty simple. I'm just going to come right over here. I'm going to disable the primary to the ignition so we can crank it over and it's not going to start without any primary fire going to the spark plugs. Now what I do, I say yes to that. And when I say this, yes to that, it says go ahead and zero and put it on. I put the probe on so we're ready to go. Hit enter on that one. It wants me to zero it. So I'm going to pull it back off, which is a good idea. Zero it, hit zero. And when I zero the probe, now we can go ahead and put it back on. It's just zeroing it internally. Now, while it's back on, it says go ahead and start the engine. So we're going to start cranking the engine. Now, what you're going to see when we're cranking it, you're going to see a timer here, which is going to actually time down so it can read. And on the other screen, we should see the amperage as it's actually drawing it down to the starter. I got Chase inside the car, so Chase, go ahead and crank it. Great. All right, so it had to crank it through a whole cycle. It actually took the amps and it read the amps. Now what's going on? It says the average was about 146, the max was 150, which is good. Now always check your manufacturer specifications for yours because it may draw a little bit different. But you know, most average 6-cylinders or 8-cylinders draw between 150 and 300. Be careful if you're messing with diesels. They can draw 600, 700, 800 amps. So make sure you check your manufacturer specifications for the draw for your vehicle you're working on. Now, what if you had a high draw? Well, a high draw could be mechanical resistance. What is mechanical resistance? Maybe the engine's seized up, thick oil, or the pinion's in contact with the flywheel and it's very hard to turn. You can also have a short. The armature in the starter could be shorted, and that's going to draw a massive amount of amperage down there. So this is a real good test. Now, if you have low amps, well, that's either some kind of resistance where we're not getting voltage down there, or you can have a pinion problem where it's just spinning, not even making contact. It's not going to take much to drive it if it's not contacting the flywheel. Now, these tests right here with this load test will tell you what's going on with the starter conditions. That with the voltage drops, we're almost there. We just need to look at how to shim a starter properly. Well, we got the electrical diagnosis down pat. Let's turn our attention to starter shimming. And I want to show you a couple things. Inside the starter here is the actual pinion. The pinion actually comes out and it drives the flywheel. Here's one out. This is a whole armature assembly with the pinion located right here. All we need is a flywheel.
I got one right here. Look at this, man. It's 8 up.
It sure is, okay? Now here's the deal with the pinion to flywheel clearance. We want to get the pinion right up against the flywheel. And I'll tell you how to do it perfectly. You can take a look at this graphic right here. And on the graphic, you can actually see this 20 thousandths feeler gauge in between the flywheel, which is in blue, and then in green is the pinion. If you can get it in between there, you're going to have perfect clearance every time. You're not going to have any issues like this. Now, a couple other tips for you. Let's say you're cranking the car and you get that continual whine, that high-pitched whine while you're cranking. Well, a lot of times the starter's actually too far away from the flywheel. So if it's too far away from the flywheel, you want to get it a little closer, you may have a shim. You want to go ahead and remove that shim. It's going to bring it a little closer to the flywheel and you'll get rid of that. Now, just the opposite. What if you're cranking and cranking and cranking and you let go of the key? You know the sound, da-da-da-da-da-da, wing! Yeah, that one right there. Well, what's happening, it's too close and it's binding up with the flywheel. So in that case, you want to add a couple of shims, and when you add a couple of shims, you'll pull it away a little bit from it and keep testing it till you get that sound about right in there. That's going to cause it not to have any problems. Now, if it says no shims on it, no shims. Don't worry about it. It's going to be preset. But that's how you shim a flywheel. It's pretty easy. But if you don't, you're going to have this. And man, I don't like this at all. This actually chewed it up. That's just not shimmed right, kept eating it eventually. This is a costly job. So just taking the precaution to shim it properly, it's going to stop you flywheel damage and pinion damage at the same time.
Let's take a look at this engine right here and have, what if we had a timing problem? If it wasn't timed in correctly, we can get what we call kickback.
Yeah, and that's really detrimental on a starter. What's happening is the timing, you go ahead and butcher it up a little bit.
I'm going to mess with this time a little bit.
Yeah, there you go. And I'll crank it up. Maybe we can get it to kick back. Let's see what happens. There it goes. Man, that's a massive amount of stress on that starter.
Sure is. Now, make sure it's very, very important that your battery is in perfect condition before performing any of these tests.
Yeah, you know, and if you perform all these tests, troubleshooting a starter is going to be a breeze.